Just before I start, help me calibrate a little bit. There's no wrong answer to this, but I just want to gauge the relative level of experience with Kotlin in the room in front of me. How many people just use Kotlin every day? Show of hands. Great. And how many people have been using Kotlin for longer than 1 year? Okay, cool. 6 months? Great. Excellent. Okay, so I'm going to talk about, I guess, what I'm going to call quality of life with Kotlin. This is kind of a talk that I wish I'd heard maybe 2 years ago. Like I said, maybe on the first slide, you saw my name's Collin. Of course, I want to talk about Kotlin, that's why we're here today, but I also want to kind of above and beyond just picking through the documentation about the syntax or reading some of those kind of clean room stale examples you get in the documentation. I want to explore those tools in practice. The documentation is great, and I like those toy examples because they often serve a purpose. They demonstrate some piece of syntax or a concept without introducing anything more than is absolutely necessary to convey that idea. That's exactly the way you want your documentation, and the Kotlin documentation does that very well. However, as I'm picking up something new, like a language, I want to know what those tools do for me. And there's very few shortcuts to that other than kind of picking them up and working with them. So the purpose of this talk is to explore those tools in the context of solving a problem that you might have in front of you day by day. I kind of want to accelerate that learning curve a little bit. And as you work with any tools, ideally, the solutions emerge as you start working with them. I'm not saying that's a great way to build an iPad stand, but what I am saying is that those uses aren't apparent necessarily from the outset. So we're going to go over some pseudo real-ish but abbreviated production code examples that improve quality of life, enabled by Kotlin. So again, what I personally wanted kind of out of a talk 2 years ago was to see some of this, see the syntax being explored, those concepts appear, so that when I encounter subsequent domain problems in the next application I'm working on, I've got a way to frame those problems with those tools. So if you've used Kotlin before, as some of you in the room have, we have some experience, some over a year, you're going to be familiar with some of this, but hopefully you'll get a fresh perspective on those. But also maybe some tricks you haven't seen. And the idea is to give you kind of more than syntax. This should yield quality of life in a way that by expanding your Kotlin vocabulary. So that's where we're going. So let's go. I'll take this in 3 parts. One, I want to start with a type system improvement. Those of you that have been using Kotlin, this no doubt it just can't possibly have escaped your notice, which I'm going to call the sealed class gold rush. I'm calling it a gold rush because this was really seized upon early on for good reason. What we're going to be talking about is sealed classes, but in order to get there, I actually want to dial back the clock a little bit. I want to time travel to a few years ago when RxJava was picking up a lot of steam, especially in the Android community. Now, RxJava was a lot of developers' first brush up with observable streams. A lot of people encountered this with Retrofit, a networking library. Those Android developers in the room would no doubt be familiar with that, but the idea is to transmit or emit something over an observable stream. In the example on screen here, you've got an API call. This is defined with a retrofit annotation, but the point is there is some user object. I'm emitting that over an observable stream. Now this brought a lot of conveniences. I won't I won't talk too much more about RxJava specifically, but in order to talk about sealed classes, I just want to give enough background to get there. These observable streams came with a lot of conveniences, stuff like threading, like mapping, filtering, and a way to compose those with error handling all in one place. It also helps with a more push model of data where a change happens and you'd like to notify subscribers without tight coupling between who's emitting and who's listening. That allows for more loose coupling between application components. And that's great. And of course we saw RxJava be adopted in more than just the network layer stuff like you're seeing here. Right? So observable in RxJava terms also exposed a wave of Java developers to a more functional composition. For RxJava, that manifests in the distinctive chain look. So that is, I'm making some API call. I want to get a raw JSON response over the wire. Oh, and by the way, transform it. Make it a clean model object with some concrete types inside of it. And by the way, work on one thread, and then when you have the result, emit to me on the main thread. Now, if you've written code like this in Java, you've probably noticed an annoyance with the Java type system. Now, Kotlin addresses this, but it's right here. See that? Observables emit one type. That's kind of just how they're defined. That T type in Java ideally should be both simple and expressive. But what about that network response we just saw? Network responses, as we know, can be success or failure. And so encapsulating both success and failure in one object is not quite as convenient. It's not unmanageable, but it is a bit awkward. So just check this out. This is the response type from retrofit itself. This is a Java object, right? So it has two nullable fields inside of it. One of them is the response body you get with a success. And not all responses have a response body, so even in the success case, that could be null. You also have a nullable response body for an error, and of course not all errors have a response body, so that could be null as well. You have a quadrant of cases with these two nullables, and you have to check those. Now, I've omitted some methods on this class, but there are things like isSuccess and other methods that can allow you to take a response object and figure out from the outside what it is. This falls short of that sort of expressive, simple goal of having an emission that it just tells you everything you need to know about it by its type. The Java type system is not helping you here. Nevertheless, we have this complexity, this sort of non-homogeneous type that we need to emit through one channel of an observable. Again, this is not unmanageable, but it was never great. When I was thinking about this problem, as I picked up RxJava, I ran across a talk by a guy named Scott Woloshin. He runs the website F# for Fun and Profit. He does occasional public speaking as well. I'm going to show a little bit of F# on the next screen. You don't need to know that syntax. I'll just point out the highlights. But I was struck by a language feature in F# that solves this composite type problem beautifully. This is an F# type definition for a payment method. It's got three possibilities. One, a cash, two, a check with a check number, and three, a card with any combination of a card type and a card number. Now, you don't have to know F# syntax again, but just note the pipe operator. That's how F# defines a composition of types. So when I talk about a payment method, in this case, it could be any one of those three possibilities. Right, so in handling this in F# is also really easy. They just have this match statement. You pass in a payment method, and then depending on what that type is, it conditionally branches to whatever block of controlled code you're looking to execute. I thought, I was looking at this and thinking, God, that's beautiful. I wish I had something like that in the Java type system to clean up every observable stream I've ever had to write. And I don't live in that world. I don't want to do these instance of checks on my emissions. I don't want to introspect and look at the internals of an object to figure out what flavor of object that is. It's really awkward. But enter sealed classes. This is, from the get-go, was one of my favorite features. Those of you, again, that have used Kotlin, this can't have escaped your notice. And it's because it solves this problem exactly. And after all, in F#, which is mostly a functional language, functions have one output. It's very common that you need to cram a lot of detail into one return type. So that's what it's for, and sealed classes are fitting that bill as well. My first order of business when I saw this was to remake that response object in a sealed class. I'm going to point out a common mistake that a lot of people make with their first sealed class. We'll see that in a second, but let's just see how that plays out. I have a response object of some type, and like we said, it can be success or failure, so one of the cases for the sealed class is success, and it has a non-null body. Now we could have a case in here that's different that I haven't written down where the body is absent, but setting that aside, that'd be easy to define. Note that the other cases in here don't have to share that response body, so as I define the next, an error, I could include a status code but not a response body, and this is matching what we saw in that F# definition for a type, where it's got several different cases. But there is something wrong on the screen right now. I've seen this done a lot, and people don't necessarily set up their first sealed classes correctly, at least in these terms. And it's right there. That type parameter on error doesn't make any sense. There is no field, there's no member variable on error of type T. It just has a status code int. So defining an error with a generic type T on it doesn't make any sense. So just recall in Java how this might look. And remember in Java that there's a void type. Now, void has a private constructor. You don't go around creating instances of void, but it's a little tag you put on the end or on a parameter to say that there is an absence of type. That's basically what that means. In the cases where Java you would have to pass in an instance of void, which you can't create, it was very common to see developers just pass in null because Java doesn't care much about null. Anything could be null. Right, but in Kotlin, we don't much care for that. So what's the equivalent in Kotlin of void? Nothing. I don't mean that there isn't an equivalent. I mean literally nothing. That's a type that means void, and it's just to signify the absence of type. So instead of defining that error as a parameterized type T, we just say nothing, and then that means it doesn't have to have any type. That reduces a lot of clutter at the call site of this, because otherwise you'd be carrying around this type information at every call site. The type inference might get kind of confused in some cases. So it's going to clean up a lot of code downstream. But also, suppose in your domain model specifically, for your application purposes, it might be advantageous to define an unauthorized type. Many times that would just be like a 401, but suppose you have a combination of service calls that are going out for multiple protocols, gRPC, HTTP, a bunch of stuff. You need to jam them all into one type. This unauthorized type encapsulates everything you need to know just by its type. It says unauthorized. There's no fields on it. It doesn't include some parameter that would lend any more information, but it's kind of everything you would need to know to prompt the user to log in again. So it's just declared as an object with nothing else on it. And it's always a response of type nothing again. Finally, maybe just a catch-all for unknown errors, pass in a throwable. Right, so this is kind of the first thing I did with sealed classes, and it made me cry with joy. You can also get that sweet autocomplete. Just as a side note, someone told me there's maybe a plugin for IntelliJ that will tell you how many characters you've saved over your lifetime by using code completion. I don't know if that's true. Somebody can fact check me. I'd love to install that. But these when statements on the opposite side of handling that response type do exactly the kind of flow control we saw in F# a second ago, where I don't have to do an instance of check. I don't need to worry that if I'm handling a network error, it has a nullable response body on it. Right? So this is just that handling code made pretty. So that's maybe the first use of sealed classes that came to my mind. I did that because it was the problem right in front of me at the time, but as I kept using that stuff, as I kept exploring sealed classes and their possibilities, I was continually confronted with new problems that fell into this framing. These non-homogeneous data classes under some sealed parent. I just want to take one more example. Imagine you have some data layer class whose job is to feed the business logic with data. That could be because it's coming over the wire. It could be from a cache layer. It doesn't really matter. But the UI and the attached business logic need to know a few important details about the provenance of that data. Number one, let's say, by the way, we'll just imagine we're showing something like a Twitter feed where recency of activity matters. So one piece of data that you might want to transmit into your business logic layer is, am I looking at cached or fresh data? Right, so am I seeing something that's stale? Maybe you want to show a UI affordance like a grayed out background if you're looking at stale data. Right? Maybe you want to know also the age of that data. You have maybe a text view on screen that says last synced yesterday, and the age of that would be a way to display that. Further, suppose you also want to know, is there ongoing background network activity that is refreshing that right now or not? Modeling this kind of thing in Java is certainly possible. It's just a lot harder. There's a lot of data introspection on like take an object and figure out what it is, especially if we're dealing with one return type. We've already seen that you can do that, like with retrofit response, but why would you want to? So just imagine we're going to model that with a sealed class. There's many different ways you could slice this up, but I'll just paint one right now. There's a loading object. It doesn't have a payload. There's nothing in the cache, but it tells your upper layers of your application, I'm working on it. Next, you've got something in the cache, and you're actively refreshing. So this might be a way to emit an object that says, I'm working on it, but in the meantime, here's some stale-ish data that you can paint the screen with. Maybe you show a little loading indicator in the top right-hand corner of the screen. And likewise, maybe you have the most up-to-date data that you can possibly have. I just refreshed. Here's your feed items. There's no cache contents, there's no age because it's right now. And finally, maybe you just did a cache hit. It's recent enough that it's not prompting an overall refresh, an entire sync. Again, multiple ways you could slice this up, and these will be derived from the requirements, kind of what you want to show, what the user needs to know. If you're feeding that to your business logic layer, handling those maps almost exactly to just how you think about it. Your flow control could pivot on, hey, maybe I show an empty progress container while it's loading. Maybe I show the cache contents in the recycler view and then use a small loading indicator to indicate that I'm currently refreshing something. Maybe I just paint the screen with the current data and hide the rest of the UI if sync is complete, and so on. Sealed classes have really made modeling easier, and just as a parenthetical off to the side, a bad model will take all your easy problems and make them extremely difficult. A good model will take all your difficult problems and make them seem trivial. And sealed classes just help you get there. I'm going to move on to my next topic. We'll see sealed classes come back, but I won't necessarily comment on them in this way again. But I wanted to also talk about scope functions. These are something that if you're looking at people writing a lot of Kotlin code, these appear and you don't necessarily intuit the best way and place to use them. Just to be clear, these are those functions let, run, with, apply, and also. You can write a lot of Kotlin code and never use these, and that's fine, but I wanted to comment on them here because I think these are great. And the examples are instructive, but they don't look like code you'd write, and I just want to share with you what the call sites of these actually look like for me and how they read. So let's just look at the method signatures of these. I will quickly go past the method signatures because I don't think they're really that helpful, but I wanted to point out a few things about them. One, they all look really similar to each other. There's subtle differences in how these play out at the call site, and I'm going to show that in examples, but I'll just point out some highlights. One is that those that have this extension function off of T, and T in this case is what you'll see in the official documentation called the context object. When the context object has a block declared as an extension function, which you see there, those mean that when you're inside the scope of the scope function, T appears as this, which means it kind of is like you're inside that object calling methods. You can refer to self as the object in question. So we'll see that in a call site in a second. Run and with both return the result of the block. So I just want to look at run specifically. This will be my first example. Imagine you have a user object with an optional avatar image. After all, not every user will upload an image. So this kind of reads like, if you have an avatar image, run this extra bit of code. This is a common theme with a lot of these, is that they play really nicely with a nullable receiver, a nullable context object. And again, that context object here is appearing as this because it's the avatar image URL. And so a nullable receiver with the question mark dot run, all of these methods, with the exception of with, play very nicely with these. We'll see that again. But again, that's just the extension function block with the argument appearing as this. One thing you should probably watch out for when you're using these three specifically is that since it appears as this within the scope, if the surrounding area of your code has similar fields or methods, it can be confusing as to which you're calling. Just look at a quick example of that. Imagine you have a custom view group. It's got several views in it. Maybe one of them is an image view for the user's avatar, amongst some other decorations. Doesn't really matter, but down the class file, maybe you have an arrange method that's placing these or configuring how they appear. Right, so again, I have this run method, and it's called on the avatar, and it's setting the elevation. But just outside the scope, there's also a similar this.elevation. That's because the view group has an elevation, and so does the avatar, and you just want to make it clear which you're calling and in what context. So here, run doesn't make quite as much sense. I also just want to point out you can omit the this, so that would just be elevation gets 6 float, and then elevation gets 0. I just put it here to be explicit, but the confusion persists, right? So these are different objects, and that's something to watch out for. With operates pretty similarly to run, except you're passing in something, and it often reads more like with X do Y, and it returns the return of that block. So I like to use this one when it reduces noise of calling something. So a quick example of that, imagine you have a paint object. Paint is one of those things where you create it and then you need to be setting a bunch of things on it to configure its appearance. And maybe frame over frame you want to animate or change its appearance somehow. It's something you're continuously doing this with. So we could rewrite this using with, and it might clean up the context a little bit. It ends up looking like this, where you pass in the paint and then you don't need to continually refer to it to mutate it. I agree that the effect here is pretty subtle, but it's all in the reading, because you're kind of saying, I'm going to focus all of my attention on this object right here. With this paint, I'm going to do something specific. And it's a way to sort of chop up your code visually and focus the reader's attention just as much as it's focusing your attention while dealing with one thing. Right, so again, with returns that block result. So you could also return it, you could also use with to compute something, like, with pass in a user object, compute their first name, comma, last name. Another use for that. I don't typically do it for that, but you might see it used like that. Just moving on from with is apply. I use this one quite a bit. We just saw previously that the result of the block was returned with the previous two. Well, this one actually just returns the receiver. Let's see how that plays out, because this one is, I like this one a lot. Imagine that paint again. It's something that we want to instantiate and then do a bunch of configuration with. If I want to do all that configuration up front, maybe I'm creating a custom view, and while I instantiate the paint and while the view is being created, I just immediately apply all the changes to that paint. And again, the apply block will return the receiver. The receiver in this case is the paint. So I'm returning that and then capturing it in a member variable. You could do all of this upon instantiation of the object. What I like about this is that it puts all of that configuration right next to the member variable in question. So you don't have to have this init block not located near it, but is doing a bunch of configuration with it. It's kind of nice for that purpose. That's probably the one I use the most, apart from the next, which is let. Now, you're likely to see this most often when people have a nullable receiver. That is, they're calling let on something that could be null. That's not because let was made to deal with those. It's more used because of the way it chains. It's defined to return R, as we're seeing here, which is the result of that block. But it ends up being useful for a graceful fallback on something that could be null. So an example of that might be, I'm trying to get a location string, something for display. I have a user with an optional home address. Not every user has a listed address, so that could be null. And I'm saying, if they have a home address, my location string for display is the combination of their city and zip. Now, there's something wrong with this code because location string here ends up being nullable as well. After all, the let block won't execute if home address is null. But what let, in this case, is good at is letting you define a fallback. So you can say, well, if that's not anything, then here's my fallback, and supply that. And that gets captured in location string. Now location string is not nullable. It's always concrete. Finally, also looks a lot like apply, but it reads quite a bit differently. Whereas apply reads like, take this object and apply these changes, like with the paint. Take this and do a bunch of configuration. Also is more like a parenthetical side statement. It's kind of, while you're at it, take care of this. I would never call also to perform a bunch of mutation. So that could be something like logging, right? So I'm building an instance of retrofit. And in addition, I just want to perform a bunch of side work. One of those statements might be a log statement. I'm using retrofit as it, in this case, which has a base URL, and I'm pulling fields off of it, but it's read-only. I'm not mutating it more. So those are the scope functions. They're not as strange as these method signatures make them look, but it's really all in the reading, and it's all in the call site. So the intention there is to give a little concrete example for each one and how you might read those when you see them in the wild. I'm going to move on to my last topic, which I'm going to call push and pull data delivery. Now, we saw how sealed classes make push data easier. We were talking about observable streams where I have one type output and I want it to encapsulate a lot of possibilities. Sealed classes help with that, but there's another side to that which Kotlin helps with quite a bit. This is something that you could write in Java, but it's such a pain you probably don't want to. So I'm going to just take us through a hypothetical example of an app that would highly benefit from this push and pull data delivery. And I'll describe that now. This might seem a little bit abstract, but I think we'll see the example come together. So imagine you're implementing a search UI. You've got this search feature where the user can enter a query string, but they can enter quite a few more refinements. Okay, they might be searching for like products or locations or recent events. It doesn't really matter, but apart from just a query string, they can also specify maybe a location around which to search, like a zip code. You could have things like a date threshold, so only show me the stuff more recent than some date. Right, so, and you can keep going, like max results, a bunch of refinements. These are things we're probably used to passing into a network call or appending as a query parameter on the URL to send to a remote API. That's nothing out of the ordinary. But in our case here, what I'm going to suppose is that our application wants the user to be able to bounce back and forth between many screens and deal with these search parameters in a way that is contiguous. So they're viewing search results in one context, they close an activity, open up another one, and it's preserving those fields. There might be multiple pieces of your application that need to know when they change. Maybe you've got a title at the top of the screen that is a composite of their query string and the zip code they're searching nearby. So find me products nearby town, right? Multiple application components could use these for many purposes, and that's the case we're going to look at. For solving this in Kotlin, you might look at property delegates. Here's a peek. So imagine we have some search parameter repository as an application component. This is just a class, but you could easily see this being on disk or in memory. It doesn't really matter. But what it's got inside of it is, for one thing, a query. This is one of the first requirements for what we just described. And furthermore, we'd like to know when that query changes. So when I set this query to a new value, I want to broadcast to whoever is listening across my application when this thing changes. So what you might do is use the word by and then define delegates.observable. Delegates.observable is in the standard library, so this is just a way to, this will call a method in the lambda pictured here, which I'll fill in a second. It will call that lambda when query changes, when query is set. Right? And how that looks is that it passes you 3 arguments. One is the property itself. Another is the old value it contained. And new is the new value it does contain. Now, again, you could do this kind of thing in Java. It was just so wordy and such a pain. It's not quite worth it. But this is much easier to maintain. So far, this is just an internal field on this repository. So what you might also attach to this class is maybe a method of broadcasting those changes. Here I have a behavior relay. So this is just an Rx Java construct that allows you to emit changes. So far we haven't described who's listening, but this is the sort of thing where if I pass around this repository, interested parties could subscribe to this relay and we'll get the broadcasts. On the next slide, I'm going to show what that broadcast looks like, and it's pretty simple, but I just want to point out that this params. In this case, I haven't defined on the slide, but this is, you can think of that as just a data class holding every parameter inside this repository. So that could be the query, the nearby zip code, whatever else they need to tweak. And we see that the changes stream, as that property is modified, I'm filling in that lambda with an accept call to pass in those new parameters to the stream so that any interested party that was subscribed, as soon as that query changes, to get all the new parameters pushed to them. Right? And you could fill this in, right? So you could fill this in with more properties inside the repository, whether they're on disk or in memory, doesn't matter again. But every time the zip changes, again, you broadcast everything. And downstream observers might just only care about one thing. Here's an example of what that might look like at the call site. But suppose I'm passing around this repository in my dependency injection. I have some application component that is doing a little bit of UI control, and it's only interested in one thing. Does it want to enable or disable the search button? And the way it's deciding whether or not to do that is when it gets an emission from this repository, it just checks, is the query blank or not? So maybe you have other UI controllers that are interested in various facets of that. You could, again, like set a title or on and on and on. But that's the sort of thing that encapsulates the source of truth into that repository, makes it so that you can set and get these properties, and then as soon as they change, any interested party downstream that needs to update gets that data pushed to them. Okay. I'm going to wrap up. There's probably 10 other topics I would love to. I think many of them are a topic on their own. One of them is function passing for stateless business logic. I also like writing good library code. These are things that Kotlin enables in spades. My hope is that by showing the examples you saw here, you'll walk out of here with a little bit larger Kotlin vocabulary, accelerating that phase of just trying to use the tools to figure out how they're better. And instead, skip to the part where they're better and be able to reframe some of the next problems you come across in new domains with those tools in mind. Thanks.